We're going to look at this video at two-body problems. Another way of saying this is catching up problems. These are typically some of the harder questions that you might get. So these would come up at AS2 and also GCSE Further Maths, the Mechanics module. You would get these types of questions. So two-body problems. These questions often involve two objects passing each other or colliding. This frequently leads to simultaneous equations involving S and T. Map out the variables for both objects, paying particular care to the time and displacement for each. So the question says, so this bit here is just the question, and then the rest is on to my solution. So it says a car P travelling at constant velocity of 25 meters per second overtakes a stationary police car Q. 2 seconds later, Q takes off in pursuit, accelerating uniformly at 2 meters per second squared. How far does Q travel before catching P? Okay, now this bit here isn't given to you. You would have to write this in. You don't get any marks for this, but for me, I absolutely need this bit for understanding. So what I've written down here, where I've typed, because my handwriting's so bad, I've said, let them meet when car P has travelled for T seconds and gone S meters, i.e. car Q, that was a police car, has gone, and it took off 2 seconds later. So it hasn't travelled for the entire T seconds, it's gone for T minus 2 seconds. But it has to cover the same distance as the car it's chasing, so it's gone S meters. Now we're going to look at the two things. We're going to look at the car P, and it's just going at a constant speed, so really we're just using distance is equal to speed times time. So big S is equal to the speed, and what was the speed of that car? It was going at a velocity of 25, so 25, and it goes for T seconds, as we say in the yellow highlighted bit. And we're also going to look at our car Q, which is a police car, I think it was, and the police car starts off at rest, so it's a constant acceleration question. Lowercase t, that's its time, is big T minus 2. It accelerates at 6, and our Sn is equal to big S. Okay, and then you can say S is equal to ut plus a half at squared. Okay, now I'll go up here and work with this. So we're just filling it in. So it's a big S is my distance. My u was 0, so that's just going to be 0 times the t, and then plus a half times my a, which was 6, times my time, which is t minus 2, and that gets squared. Okay, let's sort that out. That's an absolute mess. Big S then is equal to half times 6 is 3, and then we'll just do, that's our t minus 2, just showing all my steps here. And then do this out, do this step here, expand this bracket, because this is what very good mathematicians make mistakes on. So expand that out. T times t is t squared. T times the minus 2 is minus 2t. You have another minus 2t, so that's a total of minus 4t. And minus 2 times minus 2 is plus 4. And then let's multiply it out again. That's 3t squared minus 12t plus 12. So you have got S, big S, equals this thing here. You've also got S is equal to 25t. So what you do here, your next bit to do, is you put big S equal to big S. So that means 25t is equal to 3t squared minus 12t plus 12. Bring it all to one side, put it equal to 0. It's 3t squared minus 37t plus 12. And then we'll use the sum and product method here. You can factorize this or solve this whatever way you want. I'm just going to use the sum and product method. My sum is minus 37. My product is 3 times 12, so it's 36. Two numbers which add to give minus 37 and multiply to give 36 are minus 1 and 36. So that's going to be 0 is equal to 2t, or sorry, that's a 3. 3t squared, 0 is equal to 3t squared minus t minus 36t plus 12, which means 0 is equal to, take a t outside a bracket, leaves you 3t minus 1. Take minus 12 outside of bracket, leaves you 3t minus 1. I have the same common bracket, 3t minus 1, and t minus 12, which means solve this one, you'll get t is equal to 1/3, and solve this one, you'll get t is equal to 12. Okay, now, one of these is not going to be valid, and this one is not valid. Now, what I mean by that is if you look back over here, the police car goes for, where is it, over here, its time is t minus 2. So if you did t minus 2, if you did 1/3 minus 2, you're going to have a negative time, so that's not going to make sense, so that's why it's not valid. The last thing we need to do is find the time or the distance traveled for the police car. Easiest thing to do, just say for Q, you knew your U was, over here was 0. Let me just write that in and I'll zoom in. Its time then is 12 minus 2, because it was t minus 2, so 10. Acceleration is 6, and we want to find the distance it's traveled. So we've got all this now. You can say your S is equal to ut plus a half at squared. So S works out to be, that's just going to be 0, plus a half times 6 times 10 squared. Fire that into your calculator, you'll get 300 meters. So not bad by the police, 300 meters it took them just to get caught up with whoever they were chasing. Okay, the next question says, next example says, a car and a van are at rest on a straight horizontal road with the van 25 meters in front of the car. At time t equals 0, so that's at the start, the van moves off with an acceleration of 1.5 meters per second. At 5t equals 5, so 5 seconds later, a car moves off in the same direction with an acceleration of 2. After how many seconds does a car catch up with the van? Again, this bit very important. Let them meet when the van has travelled for t seconds and gone s meters. So how does that correspond then to the car? I.e. the car has gone for, and it's gone 5 seconds less, so t minus 5 seconds. And for it to catch up, it needs to go the same distance the van goes, plus 25 meters. So that's why you have all this. And we're going to set this up. We've got our van, and you've got your car. So for your van, your u is equal to 0. Your a is 1.5. It was accelerating at 1.5. T, small t, is equal to big T. S equals big S. And we're going to fire that into S equals ut plus a half at squared, which means big S equals ut is going to be 0. A half times 1.5 would be 0.75 times big T squared. Super. Now for a car started off, can we see it there? Car started off at 0 as well. It accelerated, greater acceleration because it has to catch up. Went for 5 seconds less, so big T minus 5. And your S, it had to go the same distance the van went, which is big S, plus the 25 meters, because it was starting 25 meters behind. Write down lowercase s equals lowercase u, lowercase t plus a half at squared, one of your Suvat equations, and then fill it in. Big S plus 25 is equal to my ut, which is going to be 0, and then a half times my a, which is going to be just 1, times my t squared, which is t, big T minus 5 squared, and we'll sort that out. So that's big S plus 25 is equal to, that would be, like I told you in the last one there to do this out, so I've got to practice what I preach. That's going to be t squared minus 10t plus 25. Bring the 25 across, make your s a subject. S is equal to t squared minus 10t. Okay, can we remember what we do now then? We've got s is equal to something over here. We've got s is equal to something over here. So all we're going to do is put big S equal to big S, which means 0.75, and I'll zoom in on this a wee second, t squared equals t squared minus 10t. Okay, and then bring it all to all the t's to one side. You'll have t squared minus 0.75t is 0.25 t squared minus 10t. And then I would just multiply through by 4, everything by 4. That'll be just big t squared minus 40t. pull a t outside a bracket, you'll have t times t minus 40, which means t equals 0 or t equals 40 seconds. Ignore this one. And so your answer. So that means big T was what? Big T was the length of time that the van. So we'll just answer the question to say, car catches up when the van has gone for 40 seconds, i.e. the car has gone for 5 seconds less. The car has gone for 35 seconds. Okay, it's a wee bit ambiguous sometimes, these questions. Sometimes you're not too sure what way. So if I've written this down, I know I'm going to get the answer, the marks, because I know I've explained how long each of them have gone for. So they're going to give me the marks. Okay, last question for us. Tricky enough wee question, strange one. We have got, at time t equals 0, a stone is dropped from a balcony 30 metres above the ground. At the same time, a second stone is thrown upwards from the ground towards the first stone at a speed of 15. Right, let's do a diagram. Forget about what I've done so far. So you're dropping this stone downwards, and another stone is going up from the ground, and the total distance here is 30 metres. Okay, so that says, assuming that the stones collide, find the time the collision takes place. So here we have said that the meet when the first stone, this is one you're dropping, has travelled t seconds and gone s metres, and the second stone, i.e. the second stone, has gone for the same time, because they're going at the same time, but it has, for them to meet together, they have to cover 30 metres, so that's why its distance is 30 minus big S. So we can then just go start this off and say we've got our first and we've got our second. So the first one, this is one I'm dropping. If you're dropping something, it goes at 0 as its initial velocity. Acceleration is a speed due to gravity. If you go back to the video I did on vertical motion, you'll see I use the arrows to make sure they're all consistent. S is equal to big S. T is big T. And of course, we're going to use the old faithful S is equal to UT plus a half AT squared. Fill it in. Big S is equal to 0 times anything. A half times a 9.8 will be 4.9 times big T squared. And then for the one that's going upwards, it was fired upwards at 15 meters per second upwards. My acceleration is going against that because the acceleration is going downwards, acceleration due to gravity, so minus 9.8. Your S will be equal to 30 minus big S. And our time, I think was still T, was it? Yep, it was, happy days. So fill that in. Lowercase s equals lowercase u plus a half AT squared. Wee bit trickier, this one. So your S is the same as 30 minus big S is equal to my UT, so that's going to be 15T. And then it's going to be minus 4.9, so that's a half times the minus 9.8, minus 4.9 t squared. We can then rearrange that and make s the subject. If you do that, let's take a couple of steps to do that. Let's just say it's going to be 4.9 t squared minus 15t plus 30 is equal to big S. So big S is equal to 4.9 t squared minus 15t plus 30. And the same thing to do again. We're just going to put S equal to S. I'll zoom in a wee second. That means 4.9 t squared equals 4.9 t squared minus 15t plus 30. Okay, oh here, that's nice. Look at this. This was going to work out really nicely. If we bring all the t's to the left-hand side, you'll have 4.9 t squared minus 4.9 t squared. They'll cancel. And you just have 15t is equal to 30. And then t was equal to 30 divided by 15. Very good. So t works out to be 2 seconds. And that's it done.